Hello. In this video, we're going to begin investigating inverse functions. Inverse functions are two functions that, whenever composed together, they are going to equal x. So if g of x is the inverse function of your original function f, when you plug g into f, it's going to simplify to x. Also, whenever you take f and plug it into the inverse g, it will also simplify to x. This is when you know two functions are inverses of one another. Our inverse notation is f to the negative 1 power of x. So anytime you see a power of negative 1, you know that that is the inverse. Now, to find inverse functions, we must swap our x and our y's. What does that mean? So here we have a function 1, 2, 3, 4, 5, 6, and 7, 8. So the inverse of this function is going to be with a function where the x and the y's are swapped. Meaning, instead of 1, 2, it's going to be 2, 1. So here's our inverse. Instead of 1, 2, it's 2, 1. Instead of 3, 4, it's 4, 3. Instead of 5, 6, it's 6, 5. And instead of 7, 8, it is 8, 7. Finding inverse functions. Now, what if it's an actual function in terms of like an equation? So we just looked at a set of ordered pairs, but what if I give you an actual equation? How are we going to find the inverse of that? Well, first, instead of using our function notation f of x, we are going to replace it with y. We are then going to swap our x and y, solve for y, and once we solve, this new equation is our inverse function, and we will notate it with f negative 1 of x. So let's look at an example where we find the inverse when we're given the function of 3x plus 2. Remember, our first step was to replace f of x with y. Our second step was to replace x with y. Now we need to solve for y. So the first thing we're going to do is subtract 2 from both sides. Once we simplify that, we get x minus 2 equals 3y. Y is still not by itself. We still have to get a plain 1y. To do that, we need to divide everything in the equation by 3. So, x divided by 3 is going to be 1/3 x, negative 2 divided by 3 is negative 2/3, and 3y divided by 3 simplifies to 1y. So now we are solved for y. This is our inverse function. So now we can notate it with the appropriate notation. F to the negative 1 power. So f inverse of x equals 1/3 x minus 2/3. Now let's verify that this is indeed the inverse. So we have our function 3x plus 2 and the inverse that we just found 1/3 x minus 2/3. To verify, we need to take our inverse function and plug it into our original function. So here we have our original function. F of x equals 3 and then there's that space where the x is supposed to be plus 2. We are plugging in our inverse function. Our inverse function is 1/3 x minus 2/3. We now need to simplify this function. The first thing we needed to do is to distribute the 3. 3 times 1/3 is x. 3 times negative 2/3 is negative 2, and we need to bring down our positive 2. Combining like terms, we have a negative 2 plus 2. That simplifies to 0, so we are left with x, which is what is supposed to happen. So let's go the other way, because remember, not only do we have to plug in our inverse function into our original, but we also have to take our original and plug it into our inverse. So this time we have our inverse and we're going to plug in our original f of x, which is 3x plus 2. We need to distribute the 1/3. So 1/3 times 3x is x. 1/3 times 2 is 2/3, and we need to bring down our negative 2/3. 2/3 plus minus 2/3 is 0, so now we are left with x. So we have verified that the inverse function we found on the previous slide is indeed the inverse function. Now, still, same functions, but let's graph these, because graphically these two functions have a very special relationship. First, we are going to graph f of x, and it is going to be a pink line. The first thing we need to do to graph is we need to graph our y-intercept. Starting at the origin, our y-intercept is 2, so we need to go up to 2 on the y-axis. From there, we know that our slope is 3, meaning we are going to go up 3 to the right 1. We are out of room on our graph, so now we are going to go down 3 to the left 1 and connect those points with a nice line. Next, we are going to graph our inverse function, and it's going to be a green function. So the first thing we need to do is graph negative 2/3 as our y-intercept. From there, we're going to go up 1 to the right 3 and down 1 to the left 3, connecting these 3 points with a nice, beautiful line. One thing I want you to notice, the y-intercept of our original function is 2. The x-intercept for our inverse function is 2. The x-intercept for our original function is negative 2/3, and the y-intercept for our inverse function is negative 2/3. See, so our x and y's have still swapped, even though we don't have that list of ordered pairs out in front of us. That's okay. That is the idea of inverse functions. That's exactly what was supposed to happen. But here's a special relationship. This is the line y equals x. Our inverse function, our original function, is reflected across this line to establish our inverse function. So I'm going to say that one more time. Our original function will be reflected across y equals x to form our inverse function. Tune back into our next video to continue inverse functions part 2.